Hello, everybody. Welcome. Nice to meet you guys. Thanks a lot for tuning in today. We're very excited to see so many people join in here. At this moment, we're actually wondering if we have a cap of around 100 people, which we're looking into, because more than 500 actually signed up. So as of now, you could consider yourself the lucky ones, I would say. But very good to see you. Let's just get going here with our presentation. So first off, I should mention to everybody that we do record this session. So if you don't feel like getting recorded, now is your time to drop. If you guys don't see the presentation, please let us know in the chat. But otherwise, I think we're good to go. Here you can actually see one of our machines in actions. It's the project is done by PERI Group, one of our partners. So we will get to that later in the presentation. Now, presenting for you guys today is me. My name is Phil. I'm one of the co-founders of COBOD, and I manage our activities in North and Latin America. With me today, also a dear friend of mine, Zaid. He's probably the smartest man, or one of the smartest men in the world when it comes to architecture and 3D printing. Zaid.
Hello, everyone. I'm Zaid. Nice to meet you all.
And today we're going to discuss and present to you how 3D construction printing is going to transform the construction industry, making it greener, making it cheaper, faster, more sustainable, and with more design freedom. And I hope by the end of this presentation, you will have a good understanding of what this technology is capable of. And we will also have time for a quick Q&A. So if you have any questions, please leave them in the chat and we will pick them up at the end of the presentation. Now, moving on here. My presentation here is slightly frozen. It's not like we're that narcissistic and just want to look at ourselves. Just quickly before we move on, we just want to present to you who we are and why we see ourselves as experts that are at least worth listening to just a bit. So COBOD was founded in 2017. We got a big grant from the Danish government, and we spent a few years figuring out what the state of the art within 3D construction printing was. Now, from this, we decided to actually go and develop our own machines and commercialize them. Right around now, we're 65 employees. And just for reference, in January this year, we were around 30 employees. It's actually wrong there on the screen. It's supposed to say in 2019, we were just 9 employees. So we're really growing a lot when it comes to employees. And that's of course driven by the increase in sales. So we sold the first printer in 2019, but now we've sold more than 30 printers worldwide in 6 continents. And they have an average price of around $300,000 to $600,000. Now, we have actually tripled revenues in 2021, and we have doubled revenues last year. So we're really moving fast ahead, and we would say we're many years ahead of any competition with these sales numbers. Also important about us is that we have a very strong minority investor in the group called PERI Group. It's a German-based company. They operate globally. They're a formworks and scaffolding manufacturer. They have around 10,000 employees, and they have done many great projects with our technology here. Now, COBOD does 3 key activities. One is that we develop and we manufacture and sell, we would say, the world's best 3D construction printers used on site. It's this gantry system, which we will go into in just a minute. We also do great collaborations with some of the largest and most skilled companies in the world. For instance, GE Renewable Energy. We work with EMAR Group, the largest developer in the United Arab Emirates. They actually did the largest building in the world, the Burj Khalifa. We work with Larsen and Tourbo in India, which is also a company with 140,000 employees. So really skilled industry players, which helps bring forth this great technology. The third key activity that we do is we do a lot of research with our partners in 3D construction printing. And we do this in two areas. One area is within materials research. So how do we actually take a tried and tested material like concrete, which has existed for thousands and thousands of years, and how do we then make that 3D printable to be used in this new machine? And secondly, we also do a lot of what we call 3D construction principles research. This is to say we research how we can do better reinforcement. How can we print slabs for buildings, et cetera, et cetera. Because all of this machinery is no good, you could say, if you don't know how to operate it properly and how to use the material correctly. So today we're going to be focusing mostly on activity number one, which is developing these great machines. If we move on here, just before we get started with the topics themselves, I just want to say once again, thank you to everybody who signed up. We're more than 500 people that signed up initially. I can tell now that we have by mistake made a cap at 100 people. So consider again yourself the lucky ones. We will definitely be recording this and be sending it out to anybody who missed it in the first instance. And we apologize deeply for this. We didn't really expect this large a turnout. Now, we also, based on this great traction we have here today, we will definitely do future webinars. Just a few examples that we will be doing in the future. One, a live 3D print from our headquarters over in our production facilities. Secondly, we will do a webinar on common myths in 3D construction printing and busting them. For instance, you're not going to print a home in 10 hours and save 90% compared to conventional construction. Not happening. And a third point we might take up is, which will probably be driven by Zaid, is how do you design architecture for the future using 3D construction printing? So this will be a whole series of different topics that we'll bring up. There is a slow transition when we go from one slide to the next. So here we go. These are the topics we would like to cover today. What is 3D construction printing? Why is it happening now? What are the benefits? How do you do 3D construction printing in the first place from our perspective? And what is the future of 3D construction printing? In the end, we will also have time for a Q&A as mentioned before. So just a show of hands here, maybe. How many of you have heard about 3D construction printing? If you have, please use your annotate tool, a thumbs up or the emoji that's clapping, or yeah, you could just do it on your web camera. That's also fine. Okay. Cool. So it seems like there is actually a good, from what I can tell here from the screen, there is actually a good amount of people who has heard about it before. Now, today we're going to show you, of course, more about how this technology is actually evolving. Before we get going, I would just like to show you a video of just that. So this is a project done by our partner, PERI Group. And again, PERI is the minority investor, and they did this in Germany. Let's go. So I think we have some potential sound issues from the video here. So I'll just go ahead and voice it over. again, what you're looking at is a very large building, around 400 square meters. That's around just over 4,000 square feet, being printed in Germany using a COBOD Bot 2 3D printer. You can see here how the concrete is actually getting extruded through the print nozzle, which allows you to stack layers of concrete on top of each other to give you the walls of that building. And now here at the end, what you see is the additional contracting work that comes into to finalize the building. So a big thank you to PERI for sharing this video with us. Quite impressive, even for me who has worked here for a while now. So just in terms of what 3D construction printing is being used for, there's a lot of use cases that are being developed these years, and I think we will only see more in the future, right? We've seen it being used for residential housing, for schools, which we did. We'll see that in a moment. For wind turbines, also you'll see that in a moment. We've seen it used for bridges in the military, for commercial use, et cetera, et cetera. And we're just like at the beginning of this story here. We will see many more applications being developed in the future. Now, contrary to popular belief, 3D construction printing is not addressing all costs or all elements of traditional construction. That's what we've sort of tried to highlight on the right-hand side. If we look at a residential housing project, best case, the 3D construction printing technology would make up maybe 40% of the total elements and the total cost, right? You use around 10% for the foundation and slabs, then around 1/3 for the row house structure. That might be smaller than that. But then there's still a lot of other work, which as of now, you cannot do with a 3D construction printer. Maybe that will come in the future. At least that's something we're working on, right? But there's still a lot of work to be done in terms of finishing and surfacing. For instance, you need to do the doors, you have to have windows in the kitchen, et cetera, et cetera. And there are other costs behind the doors, which you don't see, which is related to, for instance, insulation, heating, plumbing, electricity, et cetera, et cetera. So we would say around best case, 40%, but probably a bit lower is what 3D construction printing is really addressing. That's also why if you hear in the media that somebody says, oh, we're going to cut construction cost by 90% using 3D construction printing, not happening, right? Because how could you save 90% if the total cost that's being addressed by the technology is way less than that? So we always try to be very transparent here at COBOD in terms of setting expectations right. Now, just in terms of the what's happening within 3D construction printing, well, it's growing a lot. I would say there are still no good sales numbers or global sales numbers that are trustworthy. We have ours, and we make up a very large chunk of the industry. But we have done an internal assessment of the number of companies, right, and the number of companies that are being created in response to 3D construction printing. And you can see here that it's actually picking up, right? Right around now, we would say we have a total of maybe 40 3D construction printing companies, of which the majority are based in Europe, but the other regions, we see them as well. However, these are just numbers of companies with regards to the success or with regards to how many have actually done proof of concept or how many have deployed printers. The number is much, much lower. And in all humbleness, COBOD is likely the leader in that aspect. But strong growth here, and it'll only continue in the future. We're 100% certain of that. Now, that was a bit about the status of 3D construction printing as it is right now. And I think we would now like to switch gears to say, why are we actually seeing this? What are the benefits of 3D construction printing? We see four main benefits of 3D construction printing and why the conventional industry is being transformed by this. One is automation. Second one is speed. Third one is just the sustainability aspect. And the fourth one is design freedom. And now we would like to touch base on on automation, sustainability, and design freedom. in general, in the world, there is an urgent need for automating manual labor in the construction industry. There are several reasons for this, which you have likely stumbled upon in recent years, even if you're not even in the construction industry. One is that the construction industry itself is not very digitized or automated. U.S. estimates says that around 50% of activities in conventional construction can actually be automated. Secondly, there is a lack of skilled labor in the industry. So we actually need good skilled hands on site, right? Which automation, of course, can replace some of. Thirdly, there's been an increase in material prices for the industry. Steel and lumber are great examples of materials that have risen tremendously in recent years. So that drives a further need to minimize cost. And then number 4, also very important, affordable housing. This is something we hear from, I don't know, at least half of all our customers. They want to do affordable and sustainable housing. So we see these 4 main drivers as reasons for why this technology now, despite having existed for actually several decades, why we see a rise in adoption. Just speaking a bit more on the savings here by 3D printing. So maybe this is your domain, I would say.
So basically, because of the aspect of automation and let's say using the 3D printer to automate the construction itself. So basically, what gain that you have over here is the complexity that you will have for almost no extra cost. So if you want to compare a flat wall with, let's say, a conventional construction and 3D concrete printing, you will end up with the factor of 1. If you have a structure with 1 axis of a curvature and so on, you would have a factor of 2. Of course, I would assume most of you are coming from a construction background, so you know the cost of a small curve would cost you a lot in formwork, would cost you a lot in finishing, and so on and so on. That doesn't happen with 3D printing. It's as simple as a digital file going to the 3D printer, and the 3D printer would do the work. The same case goes with the structure of 2 axes. Of course, this is more complex. And it's not about only the complexity, it's about finding the right people to actually do this. And because these people also are very exclusive and they're limited in their skills and in their time, that means that there's kind of an extra margin or extra cost that's going to happen over there. Well, that doesn't really happen when you're using the technology of 3D concrete printing and so on. So going on more into let's say what happens in construction, why 3D printing is interesting, why it will improve sustainability. So basically, the first thing that you will have less waste, printing only what is needing without cutting or curving or precasting elements, and so on and so on. This is all that can be taken in consideration while 3D printing. The same case goes with less enforcement, so eliminating reinforcement in precasted elements that you would use for transport. Of course, most of you would know about this. You have to have some kind of hoisting joist or hoisting points for the reinforced parts and so on. All of that will disappear if you are using 3D printing in situ or inside. And the material efficient design. And let's go back to zoom out from using this technology. Now, if you are using a 3D printer, that means that you can use construction in different ways that you were not allowed to do in conventional methods. And this is what we are trying to do here in COBOD, that we are creating knowledge and creating methods and creating technologies that at a certain way, the engineers or the architects that work with us have to change their mindset of how they design buildings. And when they do so and actually activate the powers of such a technology, we'll go up with a material efficient designs. So basically, as you can see over here, we achieved the same areas, let's say, with different shapes. By when we did so, we reduced the structure or 12% of the uses of the materials. So again, this is a key point over here on the transitions between conventional to automated construction, is the mindset and the knowledge that the engineers and the architects already have, and how they can actually put the effort and see how they can optimize the use of 3D printing and efficiency in the design. And maybe lastly, but not least, the new materials. So again, when we have this, let's say, new novelty in 3D printing, the new materials and the enabling of used recycled materials and so on. It's pretty much encouraged in the construction industry. And what we all know, that construction industry is a very, very conservative industry if you compare it to others. For the past, let's say, 30 or 40 years, we have seen digitalization of the tools that the engineers use. So we saw digitalizations of the CAD and the softwares that the engineers use, but not really the automation and digitalization of the construction itself. So what happens if we want to, let's say, start exploring how we can make this material more efficient, make this material more sustainable, optimize these materials in a global way. So each area in the world which have the printer, they will use their local materials. They will use their own, let's say, recipes, what they need for their building code, what kind of loads that they will have. Because again, we're a global company, we're international, we have printers all around the world. And what works in Europe might not work in the States, not what work in Middle East, not what work in Africa. So basically, this is what's happening right now. We're creating knowledge for each area by itself. And this knowledge is actually shared and let's say, contributed to push this technology further and further and further regarding materials, designs, enforcement, waste, sustainability in all of these aspects, and architecture itself, and civil engineering and structural engineering. So
exactly. And just one point, because we did bring some props here today, but just on materials, for instance, here you actually see it's not a piece of the Berlin Wall, but it's a piece of the BOD building. That's the first 3D printed building that we did in Europe in 2017. Now, the layers themselves are not that good looking. We have improved those tremendously in recent years. But you can see here that from the side, it's actually monolithic, right? So it's very, very strong. And if I go really close, you can likely see that we used these red, it's cross tile. So it's 23% recycled materials. So there's a lot of potential to go in and make concrete more sustainable.
If you compare it to one of the most recent, let's say, samples, you can see the amount of improvement in the surface quality. Also, we're going to go with the monolithic layer bonding and so on. So this is extremely important, not for the aesthetics as well. It's pretty important for the, let's say, the structural integrity of the building itself, what kind of material, what kind of recipe, and so on and so on. So if you look at 3D printing from a perspective, it is several amount of very complex sciences coming into one point, and that point is actually 3D printing. So you have the people from the material science, and you have the architects, robotics people interested in 3D printing, and so on. And all of them, they will meet in that small point, which is called 3D construction printing. And this is what we are trying to do, or what we are actually doing and achieving. So going back to the presentation.
So that was a bit on sustainability. And then lastly here, another advantage is, of course, the design freedom, right?
Exactly. As we talked about that, this is a tool that architects and contractors and civil engineers cannot, or maybe they're not educated, or let's say they're not practicing it as it should, because every contractor or architect, when he's drawing a line or doing anything, he will have in the back of his head, how are we going to do this? How are we going to achieve it? How much it would cost? And this is the thing that we are trying to make all of these people break free from this constraint of this box. So think outside of the box and do the design freedom. This is a very famous, let's say, 3D or additive manufacturing case that happened in GE. So basically, this is a fuel jet nozzle. It sprays nozzle into fuel engines in airplanes. And if you all know, sometimes, and not sometimes, all the time in aviation, weight is money. So as you can see over here, this jet nozzle fuel nozzle, it was going from 20 parts to be assembled into 3D printed into one part. And at a certain point, at that time, the 3D printing or the additive manufacturing was not as cost effective as the small parts and so on, but the reduced of weight was 25%. So the main cost driver in the airline industry was actually the reduction of the weight. And you can see the effectiveness of additive manufacturing is a specific case over here with the just GE fuel nozzle. And you can imagine this is one case of many that can actually take place, not only in manufacturing, also in construction and in engineering and in all different aspects of industry and so on.
Another example, this is a cool one.
Yeah, basically, well, what happens if the architect or the engineer wants, let's say, to add some kind of aesthetics to the building? The printer is already there, the material is already there. And what happens if we can actually do like a weaving wall? And what is the cost of this compared if you want to do this in a conventional method? Basically, it's extremely hard to do this in conventional method. Let's say if you want to do a mold for that and so on. And that mold will be only used for once, while if you have a 3D printer, you can do whatever you want, whenever you want. So you can also imagine what happens if you actually design these within patterns to be also load bearing or construction, part of the construction and so on. And all of this comes for free. You can see here the consistency of the material, the smoothness of the printer itself and so on. And the wall in the front as well, you can see we have some kind of a logo, our logo, COBOD, which is a bit recessed or appearing from the surface. And this was made by 3 or 4 minutes on using our own slicer, our own software. So the simplicity of doing these things and the design of the freedom, it's not only the design of the freedom of doing such things, it's the ease of use. These designs were made by interns that we had. Like you can imagine how simple it was to manufacture and do such a thing and so on. So again, this is where we are standing at the moment, and we're creating knowledge. We're trying for the people to actually get access to this knowledge and see how they can activate that and use these case uses in their own projects and in their own atmosphere and their own environment and so on and so on.
Yes. So those are, I would say, design freedom. You have automation, you have speed, and you have sustainability. Those are the 4 main reasons that we see for the increased adoption of 3D construction printing. Now, this is also very interesting. So how do you actually do 3D construction printing? A lot of pictures, a lot of photos have been going around the media, et cetera, with the finalized prints for some companies. Some are real, some are maybe mock-ups, et cetera. But we want to show you some real projects with real people living in real homes. And then we want to discuss briefly how that was actually done. So maybe you can take us through our printer setup here.
So basically, as you can see over here, this is one of the setups of the printers. Maybe let's start about introducing our printers. Our printers are gantry systems. So as you can see, there's 3 axes where the printer can move. And our printers are modular. When we say modular, that means it is actually adaptable to the size that you want. So if we can look at the printer that we have, and the x-axis where the printer is, you can see 5 COBOD logos. Each one of these logos, it consists of a module. So basically, this printer is 5 modules, which have a width of 12 meters. So you can deduct that or increase that. The same case goes to the length on the y-axis. On the y-axis, it's basically unlimited because you can just go over there and then add more z-towers or more z-legs that can hold more y-axes, and you could just go unlimited in that direction. On the height, we're at this certain point. Right now, we're limited to 8 meters, 8.5 meters at height. Of course, when you add the concrete feet, where they're also under the Z-towers or the Z-legs. Of course, these concrete feet can be 3D printed or precasted or prefabricated, and then you just do them once. You can move them along with the printer. We're going to move to the projects that you have, and then exactly this is how it works. It moves in all directions, and you have it in a modular. So, for example, if someone owns, let's say, a 444, and then he wants to extend it to a 484, so he will have the double of the length. Let's say you don't have to purchase a new printer, you just have to order the extension of the modules, and then you can add them. The same case if you have a big printer and then you have a project where you have like a smaller printable area, to fit in that kind of specific place. You can also decrease that, and so on and so on. And this is the beauty of such a project or such a product, that the flexibility and the adaptability of such a thing. On the right hand side of that, you can also see the material delivery system and the hose management system. This is something that we improved through the years, and we are still working on improving our product better and better. Of course, we have a special relationship with our clients. We always share knowledge. We always take feedback, learn from what their experiences that they had on site, and so on. And we have many streams of knowledge coming to us from different places from the world. And this is something that we are actually feel lucky that we have such wonderful clients that these clients also work with us in pushing this technology forward and forward. On the right hand side, you can see the on-site installation. This was in the States, and another picture down there is one of the projects that have been done in Germany, in PERI. If we go to the next slide. So basically, this is one of the examples what happened. This is in Beckham in Germany, also by PERI Group. This is, let's say, a high-end villa. It's a high-end villa with, let's say, a touch of luxury, European luxury. It's around 160 square meters in 2 floors, and you can see the print time was around 36 days. This project was actually one of the benchmarks in the industry, as it is, let's say, reasonably sized all around the world. It's around 1,700 square feet. If you compare it to other projects that you have been seen on the landscape, this is 2 floors. It's fully functional. It's fully permitted. It is a beautiful house that actually we asked a lot of people, would you like to live in a house like that? And we had more than 95 to 98% of these people saying yes. But if you compare this project to other smaller projects of 3D printed projects, which there are not many as well, you would see that this would win more votes than other projects, because of the size and because of the technology, because of the looks, and of course a big let's say credit goes to the hard work that happened in Germany through permitting and through the architect who designed it, and through the other contractors that done other, let's say, trades, and German engineering in general. They're spot on. You can see that this project was well done.
And I think another interesting fact about this project here is that you can see that the total print time was around 36 days, right? Of which 28 days was the ground floor, but only 8 days were spent on the top floor. So it just goes to show that the learning curve is very steep, and quite quickly you improve when doing these projects.
Yeah, of course.
And I guess this is also something we see on the next project. Just before we jump to that, note here that we're talking about 160 square meters, or around 1,700 square feet, in 2 floors, and it took around 36 days. Now we're going to jump to the next project. So 380 square meters, or just over 4,000 square feet. So we more than doubled the size of the building itself by our partner PERI. And now it's in 3 floors, not 2, but it only took 21 days, right? It didn't take 36 like the one before. So jumping from one project to the next, an immense increase in production, in construction efficiency. Quite interesting to look at.
Of course. And again, if you look at it, this is the second project. If you look at the third and the fourth projects, which I believe they will be out soon, you will see the reduction in print time even more and more. And this is basically what happens when you're the first time you drive a car or you drive a bicycle. And this is an analogy that our boss Henrik, actually our CEO, always uses in describing such a technology. So this is something also happens when you have the, let's say, the curve of experience. So you know how to do things. You would do it better. You would do it faster. You do it cheaper. You do it efficiently. You would actually know some kind of how to direct your contractors and decide how to do these things in a better way, and so on. Again, it included load bearing walls and non-load bearing works and so on. But the key factor over here is the size. So this is also something that we in the industry always notice, that the scale of the buildings that you have, and when you compare the scale to the time of the print. And this is a really extreme good example to what you can see over there. And maybe this is different from the project that we saw for the first example, because this imitates the conventional methods of construction. It's a normal box house with a pitched roof that functions better than the normal conventional methods. You can see also the architect over here decided to keep the 3D printed walls as is to show the value of 3D printing and so on. Of course, that maybe later on we will talk about this, that we have technologies or tools that can make these aesthetics look better and imitate the, let's say, normal look in a different way.
Exactly. Yeah, we have more. We have a lot of projects, so we'll just go through them a bit quickly now. Now you've seen a few good examples, so just to have a few more. These are two projects by our distributors in the States. We have Allquist 3D. They're printing in Virginia, finishing up that home, and then Printed Farms in Florida, also printing over there. So again, just speaking about like how this is deployed, our technology is deployed all over the world in different temperatures, different humidities, with different building regulation codes, et cetera, et cetera. So very, very versatile technology that's being developed here. And it can be used for other purposes than just residential housing, right? So Holcim here, Holcim is the world's largest cement and concrete supplier in the world. And they have a joint venture that's called 14 Trees. They actually printed a school in Africa, in Malawi, and they did so in only 18 hours. So it's just a very, very cool use case. And you can see the kids are in there. They're happy. I guess they're happy. I wasn't too happy going to school back then, but they look happy at least. And it's just a fascinating use of that technology.
Maybe it's worth saying that it's the technology itself is such a tool that you can actually control the level of the finish or control the level of what product that you want to do as a building. So you can go with, let's say, baseline, basic, let's say, low-end projects like what happens here in the school. And then you can compare it to the luxury end of houses like what you saw in Germany. So basically, this is determined by the designer and the engineer and the way that you implement the technology. So this is a very important point to show or to see.
100%. Yeah. And that also goes, I guess that point goes also for the next project, which is, this is our collaboration with General Electric Renewable Energy. We're developing with them wind turbine tower bases. The idea is to, on site for onshore wind turbines, you would actually print these tower bases on which you would stack your regular wind turbine. Now, why do you want to do that? Well, wind turbines, they generate electricity, and the higher you are in the air, the more electricity is actually being produced. However, these days, these onshore wind turbines, they max out at around 100 meters in height, because if you want to increase the height further, then you have to increase the width or the diameter of the base. But that's not possible because the trucks, the flatbed trucks that these elements are transported on, they don't allow for it. The roads are simply not that big. So instead, you can circumvent this by 3D printing the tower base on site, stack a regular sized turbine on top to generate electrical output. Now, this example here, it's 10 meters or just over 30 feet. It took 3 weeks. That was in 2019. We did it less than a year later, and then we did it in just 3 days, right? So we went from 3 weeks to 3 days, and more than 100 tons of concrete was used. This was actually the first time. The second time we did it, more than 50 to 100% additional concrete was used. So immense increases again in efficiency. Now, just a matter of fact, when you see here on the output side, it's not like we printed President Biden. However, an outcome you could say of this was that GE actually, their CTO of GE Renewable Energy, Danielle Marfeld, she actually presented this technology to a leader summit on climate that President Biden initiated. So we're very, very proud also of this collaboration with GE, of course. I think we're sort of getting to the Q&A shortly. So let's just quickly go through how you go from design to actual print. Oh, wait, sorry, just a bit. It's 2 minutes. This is just an overview of all the great projects our partners have done. A lot of world's first around the globe. Again, 30 plus printers sold. They've been used to do the first 2, 3, and 1-story building in Europe. wind turbine tower bases, affordable housing in Africa, schools, housing in the States, et cetera, et cetera. A lot of great things going on. And here, just speaking to that, an overview of where we have sold these printers. Matter of fact, we're actually opening up 3 new offices in the new year because we're growing so much. So we're opening up for the Middle East, for Asia, and for North and Latin America. So as a matter of fact, you'll be moving to Dubai. I'll be moving to Florida next year. Really looking forward to that. And that brings us, closer to our customers and new and existing ones, right? So really excited about what's going on and the width or the breadth of our customer base, as you see on the left-hand side. So maybe you're the architect expert here. I don't understand it really, but can you take us through how we go from initial drawing to the finalized print?
So basically, I would encourage all architects and engineers who's involving in this kind of let's say technology and they want to, let's say, design the buildings and so on. They have to understand the technology better. What can the printer do? How we can do it? And the thing as well is not to limit yourself to what you are doing and imitate what you are doing with using the 3D printer. It would be more like how you optimize the thing. So basically, you would sketch initial drawings for conventional construction, and then after that, you would see how you can adapt it to the 3D printer. And then you can convert your CAD files and insert it to the slicer application. So the slicer application that we provide to our clients is, let's say, a translation tool that will translate normal CAD drawings into a G code. Of course, there's different methods to actually create a G code by different softwares and so on. But because of our, let's say, wide, let's say, global clients and a lot of people with let's say limited background in the new softwares and so on, we created we created, let's say, tools to move on with the existing infrastructure. So this is why we created the slicer. After that you can actually create a G code, and then you load that G code into the printer, and then you can install the 3D printer and print on site using the material feed system, which is the concrete, print the foundations, the walls, potentially slabs and roofs, and so on and so on. And after that, as we mentioned, it's the 3D printing concrete or the 3D printing technology and construction would take about 40 to 45% of the building. Later on, you have to apply the finishing, like integrating, let's say, plasters and tiles and toilets and so on and so on. Some of these trades will actually take place during the printing, like installing the electricity and plumbing, piping and conduits and wiring can take place while you are printing. And a really good example of that, one of the electricians that usually worked in one of the PERI projects, he told us that he would spend something like 12 days in a construction site, while 3D printing, he only spent 2 to 3 days. So you can see also that there is some kind of a reduction in the work that's going to happen if you plan your project in the right way and the right process. And of course, we have that knowledge and we always convey that knowledge to our clients and so on in different places in the world.
One thing I find really cool is that, when you do the digital file of the print, the final print, well, that can actually be deployed at different types of printers. So it doesn't even have to be a 3D construction printer.
Yeah.
So just as example, this photo that you see down there at the left-hand side corner, and which is then also on column 2 and 3, that's the same file we've actually been using here. So we can actually take the drawing that Zaid and his team creates, print it out, see, okay, do we want the window there? How should it look from the top, et cetera, et cetera? How do we want the room to be separated? And then you can 3D print it in concrete once you're fully ready. So a lot of versatility in this method. Now we'll quickly jump through the future of 3D construction printing. The overall message that I want you to get here is that it's bright, and we will only see more use cases and more efficiency coming in the future and increased adoption. This I'll jump over. Basically, what we see is, right, we're moving onto a new S-curve of technology. So conventional construction, automation has not happened a lot in recent years. However, we believe 3D construction printing will actually take us onto a new curve of automation. which will come with a lot of benefits, those that we went over before. Now, we think there are three drivers that will take us there even further. One, improvements in technology, right? It's going to be more reliable. We're going to increase the speed, the material, it's going to get better, et cetera, et cetera. Also, we will see new features being deployed. We're working on a lot of features here internally, which we'll gladly tell you more about in the future. It's something that we'll launch next year. It'll essentially take our printers from being just printers to actually like fully fledged construction robots. So a lot of exciting R&D happening on our end together with our broad partner base. The second driver of increased adoption is, of course, the increased scale. Now, we're already at 3 floors. We can print up to three floors, which is a lot more than any competitor if you look at actually completed projects. However, next year, we're going to go even bigger, a lot bigger. And very excited to tell you more about that in the future episode. And then thirdly, of drivers of adoption, we're going to see new use cases being deployed. Can you print underground? Can you do warehouses, garages, et cetera, et cetera? All of these are getting, discovered and developed as we speak, and we're happy to also drive that transition. Yeah. So just to recap here, these were some state-of-the-art technologies back in the 80s. A nice laptop, a nice handheld phone there. But this is where we are today, and it's just going faster and faster. We believe this is going to be the same for 3D construction printing. Now, I think for that, we have 10 minutes left for the Q&A. I believe our tech guy, Marcus here, whom you met in the beginning, he's been taking notes as to your questions. So now we'll try to answer as many as we can. Thanks a lot for listening so far. Okay. I hear here that I have to unmute you, or you can just move to the mic here, I guess. Okay. Marcus is now going to jump come from behind here.
From backseat.
From the backstage.
Hello, everybody. You saw me shortly in the beginning. Hi. Yes. So what I did during our webinar was to basically collect the questions that were the most frequently asked. Since many of our potential participants were also, let's say, on LinkedIn reaching out to me privately, I also noted down these questions. Again, to everybody, if you also know people who are not capable of joining, we will privately follow up with the video of the webinar, of the recording. So, you both. The first question was about print quality, maybe coming to you, Zaid. Mm-hmm. How do you ensure high quality of prints under extreme environmental conditions? Let's maybe start with strong heat and strong cold.
Okay, so basically this is more than 60-70% material dependent. The quality of the material would actually determine that. Of course, there is some tricks and solutions that you can add to your printing method that you can actually ensure that you would have a better print quality. But in essence, it's pure chemistry to the materials itself. Of course, because we had experience in such conditions, I would rather say avoid having let's say complex processes. Make your process as simple as possible. Use a relaxed material, use a simple material, and so on. And then these materials will actually help you to achieve better quality in printing.
Okay, great. Yeah. The second part of the question, also again with extreme environmental conditions. Some of our potential customers, interested people, are living in seismic zones, so potentially earthquakes. How do we ensure high quality prints there as well?
Okay, so let me understand it better. When we are saying high quality print, so are we talking about the print of the quality itself, or are we talking about the strength of the materials, the strength of the structure, the structural integrity, and so on?
Yes, the long-term strength of the material.
So we're talking about the end product.
Yes.
Okay, so basically, as a starting point, all 3D concrete printed, or all the 3D printed concrete is by default higher in compressor strength compared to normal concrete. This is something known in the industry since day one. It's not about only the material, it's about how do you deposit it and how you design your wall. Because you have the freedom of design, you can design your walls to be thicker. You can design your walls with different geometries that can actually assess you in these load calculations and so on. So basically that can let's say help you with that. Regarding the performance of the building itself, we had several examples, and of course working in Europe with the German regulations, which is very strict and so on, we achieved R values or U values in such conditions, which is way higher than the conventional methods. Because we optimize the wall itself, we optimize the void between the double walls, we optimize the thicknesses of the walls and so on. So at all, I find achieving such a thing and when using 3D printing is way easier than achieving it in a conventional method, and even faster. I don't see that an issue. Going to earthquakes and wind loads and so on. At the end of the day, we're a technology provider. We produce and we manufacture printers and so on. And one of the challenges in this industry is regulatory affairs. So, of course, everyone will be, let's say, scared of things that they don't know how they work and so on. But after the first pilot project and so on, as a proof of concept in that area with high seismic loads or with earthquakes and so on, having the local engineers understand how the technology works and then design for the proper machines or for the proper means of how the building is going to work would do it. But it only takes you one project to learn these things. And then the second project will be better and the third project will be better. And this effect we have seen over here, it's like dominoes. So when the first, let's say, piece goes, it all goes after it. This is what happened in Germany, in the States, in Europe, and in different places. So it takes you one to be really, let's say, you have to jump the pool once and that's it. And then you will learn a lot, and then I don't think that you will face any of these issues. Actually, we did a lot of these. We have challenged even more than wind loads and earthquakes. We printed towers for windmills, so I think this is easy peasy.
Okay.
Yeah.
Coming to the second question, and I think Philip, you can start on that one definitely. Some of our listeners asked. There are two different versions. So we have the mortar version and the concrete version. Mm-hmm. What are the major differences and what are maybe the applications you look for each of the two machines?
Got it. Yeah. And thanks for whomever asked it. So it's actually something that's quite unique to COBOD is that we do open source materials, right? So we have two versions for feeding materials. Either it's a concrete batch plant, or it's a mortar version with a silo and a mixer pump. For most purposes, we recommend the concrete batch plant, in which you create your own concrete and you add what we call a magic mix or a special solution with several additives that makes the concrete 3D printable. Now, the upfront investment for the concrete batch plant is a bit higher compared to the mortar version. However, the concrete batch plant material is 8 to 10 times cheaper than a mortar version. So even though the upfront investment is a bit higher, it basically means that over the long run, if you do more and more projects, then because of the materials, it'll make up for the cost, the higher upfront investment. That being said, we do sell the mortar version, right? So for many R&D institutions, for instance, where you're indoors and there's a smaller need for actually adjusting the material itself, because in a mortar version you use a ready mix, dry mix, right, and then add water. So that's the only two things that you really add. So you have less control, which is suitable for indoor. Let's say you're doing indoors, let's say you want to test materials, and maybe in less, you could say, extreme temperatures and humidities.
Okay, cool. We have two more questions regarding the future of 3D construction printing. I mean, it was called Now and in the Future, so now we have two for the future here. One person privately asked me, how long will it approximately take until I can order a 3D construction company anywhere in the world to print my home? That is more of an estimate from your end, open question, but what do you think about that?
A very good question, very hard to gauge. But what we do see is that, at least on COBOD's end, is that a lot of our distributors and customers, they get a lot of traction for different projects around the globe, especially in the States, recently in Florida, Virginia, etc. they see a lot of traction. People inquire about projects they want to do. With regards to when it'll become readily available worldwide, that's very hard to say. But we do see a huge increase in the number of our customers that perform these services.
We also had the question with regards to future, and this is the last question we wrap up with. Under which circumstances do you see the biggest amount of applications in the future? We have many potential customers approaching us about housing projects, mass housing, luxury housing, but also wind turbines, and you mentioned also different other applications. Where do you see the biggest market going forward, or is that something that is difficult to predict as of now?
Also a very good question, but very hard to assess. I think, looking at it right now, we see a lot of activity in residential, but I also believe we will see a lot of activity in the future for commercial applications, like we went over before. But if we just circle back to that photo we showed you before with the mobile phone and the laptop from the 80s, nobody back then, at least very few people, probably thought, okay, these are the use cases that we're going to see 30 years down the line. So for us to sort of say what's going to happen with the technology is very hard. We try to figure it out. We try also to steer and develop ourselves, but the future will tell that. Very good questions.
Okay, that's it from the question side.
Thanks. And remember, everybody, that you can also go on our website where we have a thorough, I would say, Q&A section in which you can find answers to many of these questions. If you email them to us, you can also find email on our website or on LinkedIn. You can contact us. We can also get back to you with answers to your specific questions. Now, we want to say thank you to everybody who joined in here today. More than 500 people signed up. We apologize that we could only take in 100. We will definitely make sure to fix the technology, our Zoom application in the future, so we can take in more than 100. We will distribute this video in the coming weeks to everybody, also those that couldn't attend. Once again, apologies. And so I want to say thank you to all who attended, all of our partners in the industry who have developed these great projects that we went over. Thank you to you, Zaid.
Thank you for having us.
And thank you for everybody from COBOD who made this happen. We look forward to our future webinars. For instance, come see a live print from our production site. Thanks a lot, and we wish you a great day. Cheers.